A team of archaeologists at the University of Oregon have found one of North America's oldest human-occupied sites in southern Oregon.
What were the dates of those footprints?
I work for the Bureau of Land Management in Burns District. I've been the district archaeologist here for 21 years.
For generations, researchers were confident they understood when the first humans arrived in North America. The timeline was clear. The debate was over. Or so it seemed. Then, an unexpected excavation at a long-ignored rock shelter in central Oregon forced scientists to rethink everything they thought they knew.
When humans first populated North America and how they arrived has long been a matter of spirited debate.
Hidden beneath layers of ancient volcanic debris lay signs of human life that should not have been there. Carefully shaped stone tools, animal bones marked by human hands, and faint biological traces confirming people lived in the region nearly 20,000 years ago. What they found didn't simply raise new questions, it dismantled the story entirely. The site that defied all expectations. Rimrock Draw doesn't look like a place where history would be rewritten. It's a shallow rock shelter carved into a low-rise in the Oregon high desert, far from any coastline and surrounded by dry, empty terrain. For generations, archaeologists dismissed this entire region as irrelevant to the story of early human migration. The area was considered too cold, too isolated, and too harsh to support human life during the Ice Age. According to every established model, people arrived here much later, long after the glaciers retreated and the land became hospitable. When researchers from the University of Oregon first arrived at the site, they weren't searching for ancient humans at all. Their original goal was simple and safe: study Ice Age animals and track environmental changes over time. Based on everything they knew, they expected to find shallow deposits from the end of the glacial period, mixed soil, natural debris, and perhaps some animal bones scattered by predators. No one anticipated that the ground beneath their feet would contain evidence capable of rewriting American prehistory. The first sign that something was different came almost immediately. As excavation began, the sediment layers appeared remarkably clean and undisturbed. In most open shelters, soil becomes chaotic over time. Roots penetrate downward, animals burrow through, and water washes material from one level into another. But at Rimrock Draw, the layers sat flat and separate, stacked in perfect order like pages of a book. Dark bands marked periods of activity, while lighter bands showed gaps when the shelter went unused. This kind of preservation is exceptionally rare, and it meant that whatever lay beneath could be trusted to tell an accurate story. As the team dug deeper, stone tools began to appear. These weren't random rocks cracked by natural forces. They were carefully shaped implements with deliberate edges designed for cutting and scraping. More troubling still, they appeared at multiple depths, separated by long stretches of time. This pattern suggested that people hadn't stumbled upon this location once and moved on. They had returned again and again over thousands of years. The shelter wasn't an accident of survival. It was a destination that early humans remembered and sought out deliberately. Every additional inch of depth pushed the timeline further back and made the contradiction with accepted history more severe.
Probably the most important track site in the Americas, both in terms of scale, geographical scale, but also in the frequency of track.
The tools remained consistent with human craftsmanship. The layers stayed intact. Nothing suggested contamination or disturbance. The site followed every rule of proper archaeology while breaking every rule of established history. Evidence sealed beneath volcanic ash. The moment that transformed everything emerged from deep inside the shelter, hidden beneath a heavy layer of volcanic ash. Archaeologists discovered teeth and jaw fragments belonging to Camelops hesternus, an extinct giant camel that once wandered across North America. This enormous animal stood almost 7 feet tall at the shoulder and vanished from the continent thousands of years before humans were thought to have reached Oregon. Discovering its remains was shocking enough, but the location of those remains within the soil made the finding catastrophic for the old timeline. The camel bones weren't spread randomly, as would be expected if the animal had simply died nearby or been carried in by predators. Instead, they were packed closely together in one defined spot, arranged in a way that only appears when an animal has been intentionally processed for meat and materials. Natural processes don't arrange bones like this. Something else had intervened. Detailed inspection revealed obvious cut marks on the bones. These weren't faint scratches or unclear surface damage. They formed straight, repeated lines focused at joints where meat is typically removed from the skeleton. This is precisely the pattern left by stone tools during butchering. The marks aligned with human activity exactly, and no other explanation could explain them. The volcanic ash layer sealing these remains originated from a known eruption of Mount St. Helens that occurred over 15,600 years ago. Volcanic ash spreads quickly and settles uniformly, creating a clear time marker across vast regions. Once it falls, anything buried beneath it cannot be younger than the eruption itself. At Rimrock Draw, the ash layer was fully intact and undisturbed. Nothing from above had broken into the layer below. The camel remains were fixed in place beneath a geological time stamp that could not be dismissed. Then the radiocarbon results arrived. Scientists dated the camel tooth enamel directly, avoiding any doubts about association or context. The result returned at roughly 18,250 years before present. This wasn't a marginal estimate or an uncertain reading. It placed the camel and the human activity linked to it thousands of years earlier than the accepted arrival of humans in North America. Stone tools that revealed intention and planning. After the camel tooth shattered the timeline, archaeologists needed final proof that humans had actively worked at this site. That evidence came from the stone tools discovered in direct association with the butchered remains. These tools weren't crude stones grabbed in desperation. They were deliberately crafted scrapers with sharp working edges created for specific purposes. The material itself revealed part of the story. The scrapers were made from orange agate, a distinctive stone that doesn't naturally occur anywhere near Rimrock Draw. Local rock types are entirely different in color, texture, and fracture behavior. This meant the material had to be carried from a distant source. Either the people who used these tools traveled long distances to collect the stone, or they acquired it through trade networks with other groups. In either case, this showed planning and social organization far beyond simple survival. Under magnification, the tool edges showed wear patterns that only developed through repeated use on animal tissue. Tiny fractures followed predictable paths caused by pressure against meat, hide, and bone. These patterns match exactly what experimental archaeologists see when modern replicas are used to butcher large animals. The Rimrock Draw tools weren't made and discarded. They were used repeatedly over time. One scraper pushed the timeline even farther back. It was recovered from a sediment layer deeper than the camel remains themselves. Because undisturbed sediment builds up gradually over time, deeper layers are always older than those above them. The clean, intact stratigraphy at Rimrock Draw confirmed this tool was deposited earlier than the camel butchering event. Humans were present at this location before 18,250 years ago. Microscopic evidence that sealed the case. The final confirmation came from evidence unseen by the naked eye, but impossible to ignore. Residue analysis studies microscopic traces left behind when tools are used on living material. When a stone edge slices through flesh or scrapes against hide, fluids and proteins are pressed into tiny cracks and fractures on the tool surface. Over time, these traces dry and become permanently trapped. Scientists selected stone scrapers that had already been identified as functional tools based on their shape and wear patterns. After careful cleaning to remove modern contamination, the tools were tested under controlled laboratory conditions. Using protein residue analysis, researchers isolated biological markers still preserved within the stone. The results matched the blood proteins of Bison antiquus, a massive Ice Age species that disappeared thousands of years ago. This wasn't modern bison or a closely related animal. The protein signature was precise and unmistakable. The tool had been used to process a bison carcass directly. This evidence bound everything together. The stone tools, the butchered animals, and the humans using those tools were now connected biologically, not merely by physical proximity. The tools weren't objects that just happened to lie near animal remains by coincidence. They were the instruments that acted upon those animals. Someone stood at this exact spot, held these stones, and used them deliberately nearly 20,000 years ago. Why the old timeline cannot endure. For most of the 20th century, the Clovis first theory defined the limits of American prehistory. It argued that humans entered North America around 13,000 years ago, crossing from Siberia into Alaska and moving south through an ice-free corridor between two massive glacial sheets. Everything was expected to fit within that framework. Rimrock Draw destroys this model through simple geography. At 18,500 years ago, North America was locked in the last glacial maximum. Ice sheets covered most of Canada and blocked the western interior. The Laurentide and Cordilleran ice sheets had not yet separated. The corridor that Clovis first depends on didn't exist at the time. Humans were already living in Oregon. The only explanation that fits both the dates and the physical landscape is coastal migration. Even during peak glacial conditions, the Pacific coastline remained partially accessible. Kelp forests along the shore created a continuous, food-rich environment that could have supported human movement southward. This route would have required watercraft and navigation skills once denied to early Americans, but the evidence at Rimrock Draw supports exactly this level of sophistication. Deeper layers point to an even older presence. The camel tooth dated to 18,500 years ago isn't the deepest point of the Rimrock Draw deposits. Beneath it are lower sediment layers containing stone fragments and faint signs of human activity. These deeper levels haven't been fully studied yet, but their presence suggests humans were there long before the camel was butchered. In undisturbed sediment, deeper always equals older. The exceptional preservation at Rimrock Draw means these lower layers can be trusted to retain their original order. Some stone flakes recovered from these depths already show patterns consistent with the tools found above. Their presence points to repeated occupation reaching back even further in time. Excavation hasn't reached the base of the shelter. Limited funding and preservation concerns have stopped archaeologists from fully uncovering the site. This means the full story remains only partly exposed. Each untouched layer could hold tools, remains, or other evidence that might push the timeline back even further than current estimates suggest. A new understanding of early human capabilities. The people who left evidence at Rimrock Draw were not desperate wanderers drifting through an unfamiliar land. They chose specific locations, understood complex survival demands, and made tools that showed planning, material knowledge, and repeated use. They hunted and processed massive Ice Age animals during some of the harshest conditions the continent has ever known. This level of sophistication wasn't expected for this era. The discovery forces historians and archaeologists to completely reconsider what early humans were capable of in Ice Age America. These weren't primitive survivors barely hanging on. They were organized groups with defined territories, trade networks, and the skills needed to thrive in environments once thought unlivable. What this means for everything we thought we knew. Rimrock Draw has made one thing absolutely clear. The timeline of human settlement in North America is no longer secure. What was once considered settled knowledge has been shown to be incomplete and potentially misleading. Many regions previously dismissed as insignificant now must be re-examined with fresh eyes and new expectations. Archaeologists can no longer assume that upper layers hold the earliest evidence. Deeper deposits once ignored as too old to matter may reveal human activity predating known sites by thousands of years. Every layer must now be treated as potentially meaningful rather than written off as irrelevant. The discovery also acts as a warning. If evidence this ancient existed unnoticed at Rimrock Draw for so long, similar sites almost certainly exist elsewhere. Coastal shelters, mountain caves, and volcanic zones across the Americas may contain secrets overlooked simply because researchers weren't searching for them. The implication is stark. The story of how and when humans first arrived in North America is far longer and more complex than anyone imagined. Much of it remains buried, waiting beneath soil and ash and centuries of assumptions. Rimrock Draw isn't an anomaly. It's the first fracture in a much larger truth, only now beginning to surface. And every new discovery has the power to rewrite the story of America's first people yet again.